I have some great news for you. We are now pretty much at the point where we've learned all the Java syntax that we're going to in this course. There'll be a little more, but we're very close to being able to move on to the main meat of the course, the data structures part. And so to move towards that, today we're going to start looking at a totally different type of data structure. We've largely concerned ourselves with building lists and list-like data structures like the list61b or the double-ended queue. And so now we're going to talk about sets. Another thing we're going to see in this lecture is how real Java code looks. Because of course in real projects you don't build your entire list class from scratch because someone's already done that. And the reason we were doing it in this class is because we wanted to understand the trade-offs and the complexities that come even with building something as simple as a list. But in real programs, you're not really going to think about that. So to summarize what we've done just in lecture, we built two types of lists, A lists and S lists, and those implemented this list61b interface. And through the magic of inheritance, we can write code a little like this, where we say list61b integer L is a new A list, and we can add things to it and interact with the list using this list61b memory box, and that's fine. Now, a quick note, you might say, why not just put A list here? You could, it's fine. Either way works. It's just that I wanted to demonstrate the inheritance capabilities of the language. Now, in other languages, like say Python, well, there's a built-in way to manipulate lists, right? So if you've never seen Python, it looks like this. We say L equals, and then these braces indicate empty list, and then we can append items to the end of the list. And so if we run either of these programs, we will end up with 3, 4, 5 getting printed out. Okay. Well, of course, in Java, as I was saying earlier, you would not build your own list, and instead you would use the built-in list interface and ArrayList interface. So actual Java code could look like this. java.util.list integer L equals new java.util.ArrayList. And this java.util thing here just indicates that it's part of a package of code that's called java.util. Much like what we saw with JUnit, we had org.junit.assert, etc. And so this code is a little verbose. And just like we saw with JUnit, we can say, let's import these classes. And by so doing, we no longer have to use this gigantic name, which, by the way, is sometimes known as the canonical name. And instead, we can use the simple name, which is just the bit at the end. Now, this has to do with packages, which we have not described in lecture yet, but we will see it a little bit in the coming homework, what exactly a package is. So for now, just trust me as that this is some sort of somewhat mysterious syntax that we're just going to use for now. And so here, this is what more traditional Java code would look like. So you can imagine that if you had never done any 61b ever and you don't know anything about A lists or the list interface, you could just use this built-in stuff in Java. Okay. So now let's go beyond lists and start thinking about other data structures we might want to build. So one common data structure out there is the set. And it's kind of like a list in the sense that it's a collection that you can add items to. However, unlike a list, you can only have one copy of any given thing in a set. So if you try and add the same thing twice, it doesn't get added. And it has no sense of order. You cannot get the ith item in a set. You can simply ask whether or not the set contains a given item. So an example of how you might do that in Java would be, I'm going to use the set interface. Now I'm going to declare a variable that has the set interface as its static type, and then we'll create a new hash set, which is one type of implementation. And we'll talk about what this means later in class. And then we can add items and then print whether or not the set contains, in this case, Tokyo. The equivalent code in Python is shown here for those of you who have seen Python before. So what we're going to do in this lecture is build our own array set. And for now, we're not going to have any specific interface. So I'm not going to make a set interface, though in a much later lab, you'll do something similar. Okay, so the goal then, I'm going to make an array set with the following methods. We're going to have add value, contains value, and size, and that's it for now. And I'm going to, just to keep things quick during lecture, I'm going to ignore resize. So I'm going to end this video in a moment, and if you want, you might find it an interesting exercise to try and write this class all by yourself. And if you want to do that, if you go to the DIY folder in the lecture code repo, you can pull that repository and see if you can come up with the erase set implementation, or if you want, you could just watch me do it in the next video. So that's the stage we've set. So let's get cracking in the next video.